Okay, 7:02. I don't think I should wait any time further. I really feel that I think today's attendance is worse than the last time round, sir. Okay, if it does last for one more lectures, from next lecture onwards, I'll mark attendance. For students who will not show up 3 times consecutively, come to see me. I think I need to instill some discipline, sir. This is a master level class. We're not dealing with kids anymore. Okay, spread the words to your friends. I'm not trying to be hard. I just want to bring some basic disciplines, right? If you don't show up for lectures, that's likely that you don't show up for quiz. That's actually is not something. As a teacher, of course, I care. But if you choose not to show up as adults, you fail the modules. Your personal choice. Most of you are more than 20 years old, I guess, right? You're adults. All right. I think let's do a very quick recap. What has been discussed in the last lectures. In fact, I think during the weekends, I just worry that in the last lectures, my scribble on the board is a bit messy. I also prepared a few slides to explain clearly to you what do I mean by joins. I almost can guarantee you, whether in your projects or in future work, if you need to touch on data, you cannot run away from joins. Be left join, inner joins, and right joins. So I prepared some page. Later on, I can go through with you guys again. I have not uploaded there yet because I only do it in the last night. Anybody, volunteers, do a quick recap on what have been discussed in the last lectures. There is minimally one key concept we spend a lot of time discussing details. This one I go to later. Yeah. Don't ask me to pick what we eat all the times, right? So give it a try. Who want to give it a try? Also bring my new markers, full ink, my own. Yeah. Do you want to be the first one right there on the board? No volunteer? Okay. Same thing. Bohan, are you around? Oh, you have not even shown any login records. I'll take down his names anyway. This is lecture 3, right? I think I'm authorized to do so, There's no sign. He's still interested? By no means against him, right? I just want to understand a bit more what happens to the students here. Xuan Tao, are you around? Wenqin. You know what? I don't want to keep on being disappointed. Coming from here, I choose the people from face here, right? You guarantee you can. Don't get scared. Yeah. You tell me our row numbers, random row numbers, row. Or row numbers. There's no 3. Bigger than 5, less than 10. 7. 1, 2, 3, 4, 5, 6, 7. Give me our corner numbers. Another numbers, columns. 3. 1, 2, 3. You want to give it a try? No, it's okay. Yes, yeah. If you really doesn't really not be able to answer, it's fine. You know me someone which you think can help you to answer their questions. The stuff we discussed in the last lecture. Find somebody which you are familiar with, you think can answer the questions. Yes? ETL versus ELT. This is one of the topics we briefly touched on there. But at least it's a good try. What else? Again? What pipeline? AL. Oh, data pipelines, architectures. Yes, we'll briefly touch on that. Yeah. Sorry, I don't want to pass all the stress to you, right? At least I managed to answer 2 questions. Anybody want to fill in the gaps? When you have to come to you, huh? You want to try? Yeah. Take the pens. There's one key thing, you can go to the front or draw it down. There's one key thing we spent probably more than 45 minutes to discuss in details. Start with O. Yes. Thank you. You want to explain a bit more? I'll pass you a mic so that you can share with your peers. Take a mic. Yeah, I can take the pen. Does it work?
So we talked about transaction data storage and versus analytics data storage. They should be stored in different systems, and mixing them can cause a lot of great danger. Also, the movement from this side to this side shouldn't happen so often, so we don't want to affect our transaction data, because we value there are different priorities in these 2 kinds of data storage source. For example, for transaction, we want them to be sorry, I forgot the exact, but things like it must be data integrity, is atomicity, and yes, and they must be fast. They must be data integrity, very important. But for analytics side, we can have more flexibility for the purpose of analysis. Yeah.
All right. Thank you, Wei. I think nice summaries. That we spend a lot of times to talk about data storage, right? And in different scenarios, there are different needs. On the production side, when I see production, doesn't mean that you already manufacture some things, right? In the live application side, you can't afford to have too many pull actions to put the data outside. That will generate a lot of I/O, input, outputs, sometimes cause the instability of the server, right? So, and you want to store the information in ALTPs as fast as possible. You don't bring in too many structures. And you do want to make sure every time an event or transaction happens that either is committed in a database in its entirety or none at all. You do not accept partial transactions. For example, like payments. Somebody's money bank account need to be deducted in the same time the beneficiary, the receiver's money also need to be top up. You ensure both sides happens, then you commit the transactions. Not one deduction, the other one no actions. That will call partial or incomplete. Yeah. ACID as well, right? There's one more thing I want to add in. 3NF. Normalization of the database. You don't want to group all the data elements in one big master sheet. Not to say you cannot, right? While you're dealing with small amount of data, you can do so. Expect Excel files for convenience. But when you have a massive data set, you do want to decompose them by subject and provide the foreign key and primary keys to link them properly. Later on, I think we'll go into details, and especially when we run through the codes, you guys probably will start to appreciate why I'm keep on mentions about the database structures. Why do we need to decompose between OLTP and OLAP? Are you guys still confused about this concept? Because this is almost a guarantee will appear in the quiz. I'm not seeing the same, right? But the topic itself, given the fact it is so important, you will appear in exams. Okay? We'll also briefly touch about the key data pipelines and architectures, but understand, right? I think in the last lectures, I perhaps introduced a little bit more new concepts. A good portion of you and your peers get a bit confused. So I'll say it's okay for a few new topics. I'll put it on hold. In the next few chapters, we'll revisit them in details. So today the class will focus a bit more on hands-on. Hands-on means that we're not just going to talk about theories. We're really going to touch on the code to help you run through one of the, how should I say, it's not really a forecast. It's one of the preliminary simplistic trading algorithm that people use in the past, right? We start from scratch, means that we pull in data from our online server, massage them, put them in proper format, then come out with the algorithm. This algorithm will not be the machine learning algorithm we're also going to discuss in today's class. There's a simple rule-based algorithms. Once the short-term average crisscross the long-term average, there seems to be a good indications the stock price have upward momentums. You may feel this is very simplistic, and indeed, I agree with you. But this is something has been adopted by many experienced traders in the past. And it's pretty often it works for them. Of course, mathematically you can't prove this is the golden formula will give you the money, a good return every single time. It's up to you. All right, we're also going to introduce you scripters, it's called Seleniums, helping you going to online website to crawl the informations, of course, trying to go to the website who doesn't have a strong copyright protections, right? Otherwise, you may get yourself into trouble. And script this data into a proper data frames for the subsequent analysis. All right, so today I prepared a lot of topic. I don't foresee I will be able to finish all this, but hopefully some of the basic information, like various different tools, and help you guys to be familiar with the Jupyter Notebook, and run a few cells to show you how the whole thing works, and maybe explain to you how does all this key data set in the script I share with you are linked together, right? Then you probably appreciate a bit more on some of the previous lectures concepts. For example, the ER diagrams, the entity relationship diagrams, it help you to understand the relationship across multiple different data assets. People may ask, hey sir, why do I need to understand the data relationships? It's so straightforward. I just open the data files, I can understand. All row by columns. Later on you will feel, you will see as well, right? Of course, the project, the scripts I share with you is not that complex. It's not an industry level with massive amount of tables and columns, but you will be able to show you some flavors. Why, when you have a lot of data, you have to organize and manage them properly. But before that, let's go something relatively light and easier. Progressively, I will share with you more in today's lectures. Let me open. I will not go into details because I think I also expect you spend some time on your own to get familiar with some of the tools. Not all the tools are compulsory for you to use. For example, Git. Briefly touched in the previous lectures. What does Git do? Version control and for collaborations as well. Besides Git, what other version control tools I think do you have? Bitbucket. Yeah, and during my eras, 15, 20 years ago, there's something called subversions. I guess, I don't know whether it's in use or not, maybe not, right? So for this class, I think you're going to have probably about 9 to 10 students put in the students' projects. And if each of you is expected to code, then you perhaps to have a collaboration and version control tool in place will be easy. Otherwise, 9 or 10 different developers, all of you have your own versions. Later on, we're trying to merge them into one. Sometimes it's troublesome. Of course, If the team decided to say that, I want to have a divide and conquer approach, 5 of them work on the scripts, and the other 4, maybe 5 of them focus on business case, doing presentation, doing the research. It's up to you. But I do encourage each one of you touch on the script part, right? You can decompose the project into different modules, so each one of you have a role to play there. So that's the Git. There are enough link, I think, materials on that. I will not go into details. Docker, I think we briefly touch on that as well. For those of you who try the script upload in Canvas, and the fact and the time you spend to install those libraries, probably some of you may feel a bit frustrated, especially that we have library dependency issues. Yeah, so unfortunately that I can't give you a Docker. Docker means that I package the environments and the libraries, the operating system, which I run the script in my PC, and wrap them, zip them, okay, intuitive layman ways, and upload the zip files. It's not a zip file, but I see it's a zip file into Canvas. When you download, you unzip, you go into the environment, you can start to run. You don't need to install any other libraries. So that's the beauty of using a Docker. You pack not just the source code, but also the dependency, the OS, every single thing together for people to use. That reduces the time for people to rebuild the environment, start from scratch again. Imagine if there are 1 million users, right? When I ask all of them to reinstall Jupyter notebooks, install the libraries, how much time will be taken? If I just give them environments, the login start to run, it will be different user experience. The reason I share with you the Jupyter notebook, also partially because I do want you to have a try, right? Run the code, install the libraries. In future, you guys are going to encounter all this. So how many of you, when you install your libraries, encounter issues that you can't resolve? Any one of you? No? Oh, okay. Okay, that's rare. Typically, you have, right? So typically when you install Pythons, I think especially for slightly bigger scale projects with multiple different libraries, you almost always enter into some dependency issues. Yeah, Python has been notoriously famous for that, right? Okay, and then later we'll say, right, how to help you to resolve that. I don't guarantee or have enough knowledge to help you resolve that. Sometimes it doesn't work out. You install a new version of the Python and see whether it works or not. All right, so Docker is for that purpose. Yeah. For your information, I think we're not going to spend time to explain to you what does Docker do. Python knowledge. This is something I strongly urge you to start, because you're going to use Pythons for your group projects. And later on, we're also going to spend some time to run through the trading scripts together with you. And everything has been coded in Pythons in Jupyter Notebook. There are enough details there, so I skip this. The code, I think, is a bit outdated. I think yesterday and the day before, I adjusted a little bit to make sure it's really runnable. And because Yahoo Finance have updated its API, so that I think, certain field name has been adjusted. So I also make some, but it doesn't change too much. All right. BI Metabase is an open source, I think, visualization tool, but it's not that commonly used in the industries, right? For those of you want to build some skill set which is compatible with the future careers or job interviews, I recommend you spend some time. If you really want to visualize the data, right? ClickSense, Tableaus, I think they have the free students versions as well. So you acquire some skill set. But of course, Tableau, ClickSense, or Power BI, and this Metabase, in terms of look, they don't differ too much from each other, right? So if you really want to use that in Metabase, it's fine as well. You get a concept, even though it's not exactly the same as other commercial tool. Okay, cloud. We keep on mentioning about the cloud. Yeah. So in this course, if you want to try, you can, but again, it's not a hard dependency to try. I think we do put enough so-called steps and snapshot to share with you how can you create a cloud account. In fact, for students of NUS, you probably going to have a free 1-year cloud subscriptions offered by major cloud service provider, be it GCP, Google Cloud Platforms, or Microsoft Azure. Even Alibaba also offer free students trials. Yeah, the cloud is nothing but, you can consider cloud as an online computer, right? You don't need to carry it around. Create a virtual instance of operating systems, and within the virtual instance, you can install and switch on certain services. More or less about that. Yeah. And if your team want to try, right, I say, I want to create an online instance for the team to log in to do projects and sharing the code, up to you. GitHub also can do the same purpose as well, if you know how to sync between your own laptop and server's scripts. So I want the cloud configuration, I think is for your reference, right? So we don't have so-called quiz test on how you should configure the cloud. Yeah. Yeah, that's I think that's all for the reference one. Let me switch to the other one. SQL joins. This is super important. And this is, I can share with you, even just today, somebody I think who is a associate directors from one of the reputable companies come to interview with me for a role in the bank and ask a very simple questions. Someone who claim who know how to use Python, Spark, I say, never mind. Let's talk about the basic stuff, right? When you need to query the information from a database, what is the most common ones? He can't answer my questions. He always talk about data warehouse, data mart, data lake. I say, never mind, the basic one. Are you familiar with SQL servers? He told me yes. But say, tell me a few common SQL commands or queries. Not be able to answer. Just like, you tell me you know how to do calculus, but when I ask you what is the 10 multiplied by 9, you'll see that I probably need to borrow calculators. That's my feelings. Yeah. And for anybody who aspire to be a data scientist or data engineers, you cannot do not know SQL. Because more often than not, the data you're dealing with, especially for reporting purpose, are structured data, rows and columns. Unlikely those information will be stored in SQL databases. You need to perform complex joins. You need to perform filterings, group bys. Almost cannot run away. That's also the reason, right? When people claim who are senior enough in the data field, be a data analyst, data engineer, or data scientist, I always ask the basic questions, SQL. It's so basic. Nobody can deny that there's something they shouldn't use, right? So I think last lectures, I think I do spend enough time to scribble on the board. I am not going to go into details again. Quickly skim through with you just to recap, and afterwards I will upload the slides for your reference. Left join. Maybe I begin with inner join. Inner join is the intersections, right? And this one is called Venn diagrams. Just in case in the interview, you want to explain to the interviewers, right? And you want to draw circles, right? There's a name. Venn diagrams, intersections. The data set appear in both left table and right tables. Left join, besides the common one, you also want to keep the left one, even though it doesn't appear on the right side. The same goes to right joins. Right? Last time we didn't discuss in full join, I think it's never mind. This is like a unions. This concept should be straightforward. Okay? or maybe in the first place. Does anybody have any questions or clarification to raise? What is a table? What is the table? Table is not this, huh? Yeah. What is a table? Is Excel file considered as a table? Huh? So Tanya, you want to try? Excel file is a structure table. Okay. Excel, the tool, the software itself, of course, is an application, right? The file can be considered as a storage file, so etc. Right? The table typically is a concept in the context of a database. If a square look, when I say square look, it doesn't mean that the whole thing, the data set, really have a shape. Huh? A table that you see here essentially have a square look, right? You have rows and columns. So something, if they have this shape, typically you can call it as a tables. Got rows and columns. Okay, so I come to really, very basic stuff because some of you probably come from very different backgrounds, right? I have to make sure the foundation is solid enough before going to advanced stuff. Otherwise, I'm really BS here. Okay? This is the raw data set, right? You have a few raw, okay, when I talk about joins, how many data set do I talk about? Or how many table minimally I should talk about here? Minimally 2, right? Left and right, okay? Assuming in this case, you have a left table. The left table talk about customers. It's the customer profile informations. Customer name and the customer's city or the address. You also have some index in this case. It's called customer ID. 1, 2, 3, 4, running index. But look at the one right away, I know this is Alice Johnson. People will be curious. Why you use 1, 2, 3, 4 as the customer ID? Can I just use the customer name as the identifiers? I think we have to explicitly discuss this in the previous lectures, why it is advisable not to do so. Why you want to use the unique identifiers other than names? Anyone? Name can have duplications. Consistent structures, sometimes given them at the front, sometimes at the back, right? Spelling errors, space in between the given name and family. There's so many other issues, right? So typically, identifiers use numeric numbers plus alphabetic numbers, right? You don't want to use a whole string. Okay? So this is the left tables, customer tables. Right tables, order tables. It's the thing customer have purchased. Why you need to have 2 tables? Can I just put them into 1 table? This brings back to some of the stuff we discussed last lectures. 3NF, normalizations. Or maybe in a more intuitive ways, I can share with you. Customer table typically will be updated when you onboard the customers. That's potentially maybe 1 applications, 1 database, right? Whereas the order table is when the customer making transactions. That should be or possibly be another applications, another server. So at the place, at the instance when the data are generated, they will be stored at different place. Hence, they come from 2 different tables. But if now, as the manager of the departments, I need to understand the revenue performance, I can of course go to the order table to say, what is my total sales volume? Straightforward, right? I just need to go to the order table in that application server. I do a sum or sum across all the order amounts. That tell me my volumes. When you run the business in the traditional way, no issue. You just want to month-over-month sales, day-over-day sales, help you to understand the momentums. Very traditional financial analysis. But if you want to go deeper, leverage on modern data analytics, you want to see who are the customers showing a declining trend, and who are the good customers have above average spendings. You need to know who they are. You need to know where they are from, so that maybe you can do some marketing. This is the minimum preliminary level of analysis. Hence, you may want to join these two pieces of information together. And how? You look at the key identifiers. In customer table, the key identifiers is the customer index ID. This is also called primary key. In the ordering tables, the primary key is the transaction reference or transaction ID, 101, 102. This most likely will be a running sequence, right? And the customer ID here in this table will be regarded as the foreign keys. One stands for Alice Johnson's, two stand for Bob Smith, etc. Right? So you need to stitch these two data sets together in a naive Excel-based understanding to a VLOOKUP. In SQL, you do join. And there are multiple different ways to join them. Inner join means that if the customer appear left side, it's one of my customer, right? And also making some transactions, then this information will be the outcomes. You can take a look. Not all the customer actually making transactions are. You only see 1, 2, 1, 2, 1, 5, right? Number 3, number 4, Carol White, David Brown, never have any transactions. So when you do an inner join, these two customers will not have any records. And similarly, from the ordering table here, you have a customer ID defined as 5, but somehow this guy never show up in your customer database. It's weird. How can somebody make a transaction you have no reference at all? It didn't even register as a customer. Either data is corrupted here, means that somehow it's customer 2 or 3, but somehow recorded as a 5, or something maybe in the customer tables the data is dirty here. Or maybe there's some special promotions allow no customer to make orders, and no customer all recorded as 5. It could possibly happen. So when you do inner joins, you're going to only see 1 and 2. But when you do left joins, what would you see? 1, 2, 3, 4 all appear here. But 1 and 2, you see some volumes. I can show you here. This is the inner join results. When you do left joins, 1 and 2 all appear here. But 3 and 4, because it doesn't have any transaction data at all, is all displayed as none. People will say, hey, sir, it's not so useful. It is none. It doesn't carry any information. Why do I keep here? It really depends the downstream analytic needs. If I wipe out the last 2 rows, and people make some analysis based on the first 3 rows, it may lead to a conclusion. There are only 2 customers for these companies, Allison Johnson and Bob Smith, right? And similarly, if I rely on this data set to do a total sums across the total sales amount, sum all these 3 numbers together, I might be under-reporting. Why? Because there's one guy, customer 5, have $300 transactions not showing up in the left join tables. Why? Because the customer 5 doesn't appear in the customer tables. This, when you do a left join, you'll be dropped. Come back to here. When you do a left joins, the things only appear on the right table will not show up in your results. Right? So customer 5 will be dropped out. In this case, you may want to consider to do a right joins if you focus as to have a full tabulation of the transaction amount. And you're going to see something like this. Okay? I will not go into details because this is the second time I run through a similar examples to you guys. All right? Later on, when time permits, I think we're going to look into the code. Yeah. So for all those of you, I think if you already get your PC, and do you mind just follow me? I know some of you, if you have not installed so-called the library yet, it takes a while, right? So let's get it run first. Then I'll talk about other part of the lecture materials. That's why it's just for me to test the Python versions, right? So it's nothing to do with the code you need to run. This is the one important. PAP. PAP in business world, I think something very serious for those of you who worked before. If the HR come to you, say PAP, performance improvement programs, means you're in trouble. The boss feel that I think you underperforms. Okay, all right. Depends. I think if you use the Anaconda versions, right, then you probably don't use PAP, PIMP, right? Use Conda. Yeah. So the first library we're trying to install is called Y Finance. Nothing. Yahoo Finance. We're doing a trading project, so of course you want to get some public informations for the stock price and volumes. BT? Anyone? For those of you who have tried before, what does BT stand for? Which library it is? Backtesting, okay. Matplot and Seaborn. For visualizations. Free one, right? You don't need to pay. Future. How come not yesterday? Why you need to import future? FFN. Google is your friends. Later on, there's some key statistics about the stock performance. Sharp ratios. You need to depend count on these libraries. You guys know what is Sharp ratios? How many of you don't know Sharp ratio? All understand, because you are quiet, okay? You have to make sure you understand the context, otherwise later on, when I go through the code, you will probably be very confused. Why do you need to do this? Why do you need to bring this data set? I assume all of you, your code can run now. You install the libraries. Who have problems? Cannot run yet. Okay, now. Come to second stage. This is to make sure you install some of the key libraries you need to use subsequently. Do you need me explain one by one? This one is no-brainer, right? I won't explain. This one is no-brainer. This one is no-brainer. This one, I think, when I first noticed these functions, as a C++ programmer, been trained more than 20 years ago, I always use print or printf, right? Of course, I've been using Python since about 20 years ago. I always use print. What does pprint means what? You guys know what does pprint stands for? Pretty prints. I'll say, wow. Sometimes people, I think, invent fancy names. All right? Yeah. Import Y finance as YF. In fact, sometimes during the interviews, again, not to brag, right? When we ask people, I think, some simple coding syntax, you roughly can tell whether people play around with the Python or not. For example, you ask, hey, what does PD stand for? Typically, people use import pandas as PD, right? Yeah. It doesn't mean that you have to force that to be PD, just that this is a common usage. If people start, PD? No, sure. Then you know likely the guy probably never, not saying never, is very unfamiliar or very rusty on using Python to process the data. These small little things we can check. Okay, back testing, this visualization. This is SQL libraries. Actually, for these trading projects, we don't really have to use SQL, but we're thinking for illustration purpose, right? After we extract the data using API from Yahoo Finance, we put them into CSV files, then we import them back to SQL database. Actually, you don't have to, right? You can actually pump everything into a data frame and take it from there. But for illustration purpose, I think we still do so. Then these are the core stats. This is simple check-in. I have to say, the code I think I share, if you are avid software developers, you may feel, hey, how come it's so messy? How come it doesn't follow on software engineering very well? For example, in a proper setup, right? When you have a proper projects, all those library installations you don't put with your main code, right? You put in a standalone requirement TXT files. So when you install, you take it from there. Otherwise, it's difficult to maintain. But this is working prototypes, right? But I have to highlight to you what is the best practice. Okay, then you come to here. You start to where F stand for Yahoo Finance, right? Ticker, I will choose Apple, right? You can choose other if you want, like Alphabet, etc. And try to run this and to take a download. It depends on the network speed. It usually should be a few seconds. Yeah. Let me walk around to see whether any of you have any problems. Can run? Can run, huh? Okay. Oh, so many of you use Mac. Take your time, maybe in the next 1 to 2 minutes time, make sure that I can install that and start to run. Can do? Okay, so after this is actually like a Yahoo Finance API. It doesn't have the request response, I think, that kind of format or REST services. But this function essentially call Yahoo Finance to download the ticker. Ticker, I think, is the name of their stock, right? So AIPL, Apple. Getting the data, return into this. AAPL. And you want to be prudent. Yeah. After this statement has been executed, you want to have a look, indeed, what is inside in AAPL. So you just print them out to take a look. A lot of information inside, actually. Very lengthy. Quite long, huh? Then the ARPL also have other elements inside, like institutional holders. You also list out as well. This is just for you to check you get the data download properly. It's not the data you're going to use. This is a trading exercise. The focus will be very much on the stock price. Right, the holder, okay, just have a feel, and also the key stock informations, like the financial numbers, dividend rate, etc., etc. I think for reference purpose, we're not going to use in this exercise. Okay? And this Yahoo Finance, I think, also allowed you to specify the durations during which you want to get information. So here, got a start date, end date. Of course, I mean, you don't have to use the fixed date. You can change this to 2025. No issue at all. And then you just download. Getting this to data frames. For those of you who doesn't really know what data frame stands for, spend some time to do that. I mean, even can start now, right? I'll do it very, very slowly. What does data frame means? Yeah. So again, once you run these functions, if it is the first time for you to use these functions, you're unsure. You want to take a look. Did I get the data download properly and correctly? Do a print. For those of you unsure some of the common functions for data frames, head stands for the first of the few data entries. Because if the records is too many, millions, if you want to print all of them, right, it's taking too much time. What do you want? Just have a sneak views. You don't want to print every single thing. Head is the function you typically use. And you can specify, right, if you want to see the first 5, 10, just punch in the numbers in the head functions. Then, once you get this, the data frames, you put them into a CSV, store in a predefined directories. Again, I think, well, it's been like this, but I have to let you know, it's not a very good practice to hard code the directory here. But this is a school project, so it is okay. Typically, you may want to define the directories in another configuration files. So for anybody take over your code and maintain is much easier. Otherwise, for example, right, if you don't know, if never touched on this piece of code before, you have to really scroll up and down to figure out where is that information has been stored. As compare, you have another configuration file, for example, TST, right? Define, this is my output file, this is the input file. So for anybody who even doesn't need to go inside this code to read through, but look at the configuration files, they know where to look for these informations, right? That's called good programming practice. The same goes to the library dependencies. Ideally, you should put, I think, into a requirement.txt files instead here. Yeah, I show you the bad way, so that I think you know what's considered. Sorry, not a bad way, right? No enterprise, no professional way. Okay, then after that, same thing, right? Print out to have a look. Once you productionize this, you may want to disable some of the print functions because you generate a little bit I/O. It won't slow down the things tremendously, but sometimes, right, you can optimize the performance. This is to show you every single thing is there. So we're trying to insert a lot prints to make sure every single steps we do it correctly. Same thing. After you make sure there are datas there by using the head functions, you want to check what are the columns of this data set. Why do we need to check the columns? Column is like a header, right? A, B, C, D. Later on, when you refer to the data set, you have to make sure you refer to the right columns. If the column name is A, you call column 1, you're going to have exceptions or errors. And in this case, the column is actually multi-indexed. For those of you don't know what does multi-index means, it's okay, right? You have 2 layers of index. The column name is actually called close APL, high, low, open, and volume, right? Because it's multi-index, that's why the column name seems a little bit weird if a bracket. Yeah, for the time being, assuming you have 4 columns, close, high, low, open, volume. What does that mean? As I keep on seeing that, this is not just a class talk about tech. I do want to bring in a little bit context. For those of you who have been doing trading before, you know the candle chart. Look like candle, right? So for any stock, every time when the market is open, there is always a first price. And that first price typically recorded as open. People will say, hey, sir, there are pre-recording hours. How is that? I say, never mind, right? In the simple scenarios, when the market is open, there will be price recorded when there's a transaction. That's called open. And when the market is closed, there's another price being recorded, maybe the last transactions. One is open, one is closed. In between, the price can go either way, going up or going down. You'll always have a high, you'll always have a low. So when people say, hey, they make a lot of money from stock, which price do they typically refer to? After trading for 3 years, I make $3.4 million. Which price they typically refer to? Not the high. High is only in transients, right? Going up probably will come down. Could it be open? Typically they refer to the close price. Also not the low. When the market close, settle, that means that stocks, the state's end state for that day is like that. It doesn't mean the close price is always the beginning price for the next day. Not necessarily. But typically, usually, people use the close price. So for this project, we want to do trading algorithms to figure out, based on the stock price, the movement, when should I buy and when should I sell? Let me erase this. Assuming this is the stock price, not necessarily Apple's. Right? I don't buy Apple stock, so I can't remember the patterns. So when should we buy, when should we sell? So I think many years ago, when I'm still doing the trading, I have some discussion with people who always want to know a bit more about trading. I say, this is very easy. You buy from here, you sell at top. So simple, right? You learn math enough, you will know. Yeah. You buy at the lowest and sell the highest. Yeah. What's the flaw? I think they have their trading strategies. You only see the valleys and peak when you look backwards. This already happens. Of course, you know every single thing. Right. But moving forward, how do you know this is the value you should buy? Maybe, let's say, if here is today, you think, right, this one come down to here. This is the bottom ready. You will bounce back. I should buy all in, my life savings. But moving forward, then how? Then there are people to invent to say, no, there are other ways. Let me look at the resistance levels, right? This is the lowest point in the past. Lowest point in the past. Again, I'm not sharing the detail with you, ask you to do trading. Please, for illustration purpose to understand the trading algorithm for this data engineering course, by no means I'm preach one trading algorithm over another, right? Do it and risk even want to try. I won't be accountable. Okay? People say, these have not reached the lowest before. So maybe safe for me to buy. If it's passing through here, the current price is lower than the previous low, means that people desperately ready. The stock price probably will go further down. That's a group of sorts. A lot of traders basically doing things based on this way. Many years ago, now I do not know. Yeah. But the trading strategy we are using here is different. We're not looking at this. You know, we are from US, right? We can't just based on fields like this, right? We need to do a bit of math, even though the math here is simple. We look at the average. If the long-term average of the stock price is at L1 level, for example, what is the example I used? 100 and how many days? 120 days or 150 days? Let me check it out. Oh, 200 days. It's 200 days. If the past 200 days average is at L1 price, if the last 30 days average, let's say, this is the last 30 days, average is at the L2 price, and L2 is higher than L1, means that recently the stock have a higher momentum to going higher. Hence, I make an inference or predictions. The stock price will continue to go higher because the last 30 days average is higher than the last 200 days average. Means people prefer this stock. There are more interest. Hence, I buy. Long, or in stock term they call it long. If the other way around, if the most recent average price is lower than long-term average price, means people lose the interest in the stock. I should sell, or I short. That's the trading strategies, as simple as that. The window, of course, you can fine-tune a bit, right? If you want to look at very long-term average, change the 200 days to 300 days, or even 1-2 years time. And similarly, you want to capture the instantaneous signals. Instead of use 30 days, maybe you want to use 1 week. So that's the key concepts. I think for those of you who need to try install the library run, I'll pause here for a short while, let you warm up a little bit. I'll switch gear to other use cases. I'll come back on this, I think, again, because I do want to explain to you how does different data processing happens, how do you stitch the information together. Switch gear, You guys roughly understand what does this, I think, piece of code do, right? Is to simulate a trading strategies on Yahoo, from the Yahoo Finance data, specifically on Apple stock. And we're going to show you the visualizations. We're going to show you how the data has been stitched together. And we're going to show you how the algorithm has been simulated by using backtesting libraries. But don't submit this as your project, or don't say, hey, sir, I'm not copy yours. I changed to Google, so it's a nice project. Don't do that, okay? Yeah. Switch gear. To nope, I think this one later. After I finish the code together with you, I will explain in the code how does the different table link with each other. And if you want to use the final version of the data set to do dashboards, how the data should be stitched together. But no, not now. It take a while. Where see. Where is the lecture 3 materials? Download from here. I will spend some time to talk about the business use cases and to help you to prepare your projects. Because the project alone need to have a business problem statement. It cannot be just keep on data, right? So I do want to explain to you some of the common typical business cases, use data, engineering skill set, but it can't end up there because eventually you need people to consume the data to make it to be a meaningful business problem statements and use cases, right? You guys still recall in the first lecture, I talked about 6 different steps, from data generation to all the way to data consumptions. Of course, prior to data consumptions, you also need to do some necessary data analytics. So today, I probably share with you on the step 5 and 6, data consumptions, the business use cases, as well as some of the very preliminary of the analytic technique without going into details. Yeah. You guys heard about the cross-sell and upsells. In the banking space, what does cross-sell, upsell means? Talk about cross-sell first. If your customers, you open a bank account with me or with us, if typically people see you have a CASA account, current account and saving account, and I know you are students, and your deposit average out probably 5,000, 10,000 Singapore dollars, average month's balance. After a while, I noticed, due to various spending patterns, and you seems to always use PayNow to make the payments, right? You patronize in NUS canteens, you go Shenzhen or Fair Price supermarket to purchase the things, always use PayNow transactions. I probably guess you don't have a credit card yet. So the cross-sell means I sell you some product and services you do not have yet or you do not have before. That's called cross-sell. Assuming now you get a credit card from me, right? And you pay your phone bills using Gyro. Gyro means monthly automatic deduction for your bill, right? You use credit card to do some other grocery shoppings or go to Orchard Road, buy luxury brands goods because there's some points that accumulate from the credit cards, right? Now I notice sometimes you buy grocery, you're using the credit card. But to buy very luxury items, I never see transactions in very luxury store. For example, LV. Is LV considered luxury item for you guys? Chanel? Dior? Or maybe Imus? That's supposed to be that's enough, right? High-end enough. I never see that before. So see what happens. They realize that the limits we give it to you is only $5,000 per month. Means that every single time your spending on that card cannot be more than $5,000. In most of the items in Amos, in Chinese called 爱马仕, Amos shop, it's 10,000, 20,000. It's insufficient. Of course, you're not going to use that credit card to make purchase. So I need to do you upsell. What do I mean by upsell? I need to give you a better credit card with higher limits, different perks. Maybe a black card or diamond card. That's called upsell. Upsell means you already have the product and services, but I want you to consume more. It's called upsell. So, in the banking context, is there any analytic way for me to do upsell and cross-sell? Of course. And how do I identify the customers I can potentially to do cross-sell and upsells? There are 2 ways. One, I look at the customers who's similar to you. Tanya, for example, have go to Iman's shop, I think, purchased the luxury bag before. And as his neighbors also enroll in this 5214 class, I assume you're similar to each other. Tanya have a black card, I also cross-sell the black card to your neighbors. Similarities, right? And one way to derive their similarities is by doing something called clusterings. For those of you who are new to this technique, you can consider groupings. Group similar customers together. The other approach is by doing machine learning. Of course, some people argue clustering is also a type of machine learning, just a little bit unsupervised. The other approach is to build propensity model, to draw a line, understand customer behaviors, to draw a line. Erase this. This is all the customers in considerations. 5,000 customers. I want to target for cross-sell, to give them that black card or diamond card, right? I want to draw a line, maybe here, or maybe here, or maybe here, to understand who are the customers indeed will respond to my offer. Because every time you offer something, either through marketing or send something across, there will be a cost. You of course wish you have a very high response rate. You need to understand who are the ones who will respond to your offers. So in this case, you want to cut your customers into two different groups. One is the customer you will not. The other will be they will, right? This becomes a classification problems. Divide the customer into two groups. And because you're talking about two different groups, so it becomes a binary classifications. For those of you who are relatively new to those data analytic techniques, don't worry, right? I'll give you examples. But I can't really go into details. People will say, hey, sir, are you going to cover logistic regressions? I can briefly talk about it. I won't explain in details. How about this boosting tree, random forest, ensembling model? They will not be covered in this class, right? For those of you who really have the interest, you can chat offline, or even post some questions in the chat rooms. Yeah, this course focus on data engineering. But I will give you some examples, very basic concepts about the steps number 5 and 6, data consumptions and the analytic methods. Basic one, right? So you have a flavor. How many of you know clustering? Raise your hand, please. A bit higher. Can't see. A bit higher? I'm doing samples. So it's about, okay, about I think 20 to 30. But I don't know whether it's a good representative entire class because I only see like 50, 60 students today, right? So 30% of you roughly know clusterings. No issue. I'll slow down a bit to explain what do I mean by clusterings. As I just shared with you, cluster is nothing but group similar entities together, right? Of course, I have a mathematical form, but never mind. I want to explain things, I think, in simple layman ways. Why do we need to do clusterings? Besides find customers similar to each other, a lot of times we also want to reduce the problem dimensions. What do I mean by reduce problem dimensions? Imagine now, if you are the directors of a bank looking after customer marketing functions, you have 5 million customers in your considerations. You need to find an effective way outreach to them so that you can efficiently increase your sales revenues. What are you going to do? Analyze one by one. If one customer take you 1 second, 5 million seconds, you probably by then will retire. What do? You can't deal with them individually. One way to do that, is there any way for me to reduce the 5 million data points to something more manageable? How about I group similar customers with each other? Because they're similar, I'll assume the banking needs are similar. The preferences are similar as well. So I don't need to treat them as different from each other. And that's the way for you to reduce the problem dimensions from 5 millions maybe to 20 to 30 groups. And that is how a clustering has been used in the business. Then people will say, hey, sir, then how do I derive a clusters? what are the typical cluster methodologies? One of the most common one is called K-means. Of course, you have key median, key method, right? You have key kernels as well. Yeah, but I won't go into details, right? So the example I can share with you that for all your clients, the 5 million customers, there are key attributes like their age, their income, there are, what else? Educations, their declared salaries, the income is already here. Their address, nationality, many other things, right? Gender as well, right? For example, based on these key attributes, I can group them together. But people will say, hey, sir, how do you group them? You know, if somebody's age 21, income 10K, compared to somebody 23, income 11K, are they similar to each other or not? When I see it's similar, but somebody else says, no, they are dissimilar, right? There's a 10% income difference. How can they be similar, right? Then you may want to use a little bit math to do that, right? So I'll explain the basic key means, I think, to you so that I think you roughly know what do I mean. Yeah. You have multiple data points. Assuming you want to group them into 3 different clusters. People will say, hey, why is 3, not 4? This is arts. Because my mind can only process up to 3. I'm a manager, and my mind only can process up to 3, right? Of course, typically for clusters, you maybe 10, 15 different groups, right? So for simplicity, I just want to begin with 3. People say, hey, sir, you randomly draw this. Of course, you can randomly draw this, but I'll explain the key concepts to you, right? Assuming you begin with some random centroid. What does centroid means? Because each of the clusters, you can imagine as a circle, right? The middle of the circle is called center, or called centroid. The centroid is a valid representation of all the entity within the clusters. You always look at center, right? To represent every single data points by these circles. And because the circles, let's say, is a small, right? So it's okay, right? The center are not far away from most of the data points within this circle. So they could resemble the key properties of these clusters. Centroid, center, center, center. Assuming you have 3 random centroid. You don't have to look at the circle first, right? I draw it here because I think for illustration purpose. When you do a key means clusters, you choose 3 random starting points as the centroid of the incoming clusters. 1, 2, and 3. For each of the data points, the cross here, you check its distance. Let's say this data points, right? The one here. You check its distance to center 1, center 2, and center 3. Whichever is closest, you assign the label, the central label to this data point. Obviously, this is the distance 1, distance 2, and distance 3. It's closest to center number 1. So for this guy, I will assign him to cluster 1. Similarly, this guy, cluster 1, cluster 1, cluster 1, etc. I do the same thing for all the data points. After these iterations, you will know all the data points belongs to cluster 1. right? Assuming it's this 1, 2, 3, 4, right? And because you're using key means what? Average. You compute the average of all the data points within this cluster to find a new center or new centroid. Maybe the new center is slightly different from here. Maybe it's here. And the same for this. And you iteratively, for all the data points, you check their distance to the new three centers and assign the label properly. Iteratively, you're going to see the centroid of the cluster start to stabilize. They move, but they move very tiny bits. This is how you do k-means. Then people will say, hey, sir, how do we compute the distance? Is it always Euclidean distance? So in the two-dimension x and y, right? The point here, A and B, is this. This is what? Square root. Euclidean distance. But you have multiple different dimensions. What are the ways for you to define the distance? Again, this is not a data science class, so I will not go into. But I'm just telling you that I think in your proper clustering algorithms, you need to define the distance measurements in the first place. It could be Manhattan, for example, right? This is the x and y coordinates for Euclidean distance. In some other coordinates, the distance between A and B, it will not be a straight line. It could be here plus here. The absolute difference in x-axis plus the absolute difference in y-axis sum together. So this is k-means. Once the whole thing stabilizes, you can see the total distance. The total distance between any individual data points to the associated centroid of the clusters will start to decrease. Why? Why it start to decrease? Because you always want to find a good representation to group similar customers together. That means they are compact, as compact to each other as possible. Sorry, as compared to the centroid as possible. The data points, the coordinates doesn't change, right? It's just facts. So you can say, once you shift the centroid of the clusters, the total distance between the center and the associated data points will decrease. Across iteration, you will see the decrease in total distance will be very marginal. And you look at here, you can see, you probably should stop here because any more iteration, any additional computation will not bring you a lot of decrease in distance. You can probably stop here. This look like a human's elbow, right? So sometimes people say this elbow rule that determines where do you stop. This elbow rule can also help you to determine how many clusters should you have. Just now I tell you, the number of clusters essentially is arts, sometimes not so much of science. This is the science elements, right? You guys okay with the basic understanding of clusterings? This is distance-based clusters. There are other ways to do clusters as well, based on hierarchical orders. For example, if I want to cluster people staying in Singapore into different groups, besides by look at their age, education levels, incomes, I can also look at where do they stay. And naturally, there's a hierarchy here, right? North, east, center, west. And below that, you got, let's say, for people who stay in the east side, right? You got Tampines, Bedok, right? For north, Tampines, Bedok is already one level down. You can further decompose by street, then by block. There's a natural hierarchies. You can group things based on that as well, without running those mathematical algorithms. Okay? Come back to the basic distance, basic cluster. That's one thing I think I should point out as well. K-means is the basic ones. You will not be able to reject the noise from the outlier very well. Why? Because when you have a big outliers, like far away from the rest of the data points, this guy may carry extreme X value or Y values. When you do an average, you guys all know, right? 1, 2, 4. What is the average of this? 7 divided by 3, 2 point something, right? Yeah. But suddenly, if there's another guy carry 100, average of this, right away, probably 20 plus something. Yeah, but you know this hundreds does not represent the rest of the numbers, which is single digits. Yeah, so the average sometimes is not very robust against the noise from outliers. So people say, maybe I shouldn't use key means. Means is not a good method. I use key median. Instead of use the average of all the data points to find the center, I use median values to reject the noise from the outliers. But then how do you deal with other category variables? To find the mean and median of age and income is okay, right? Math works. How about educations? Someone have a master, someone have a bachelor's. What is the average between master's and bachelor? How to do that? So key means and key median doesn't work very well for those category variables. You have the key mode. Yeah. Even the starting points, how to find the starting point of the centroid, right? Just now the example give it to you at random. It doesn't have to be random, right? There are some other methods. Even you can use genetic algorithm to do that as well. But it's beyond the points, right? I only show you the flavors. Distance-based methods characterized by k-means, a few different variations. Hierarchical methods, right? Typically you see dendrograms. That is okay, right? It's less commonly used in the industries. There's one more based on the densities, which I put in the lecture notes. Again, not very commonly used in the industry. The more common one is the distance-based methods. And key means is always the number one, not say go to, number one talk about methods. In the interview, when people see clusterings, you ask me, have you ever heard key means? If the guy hesitated, you know he's bluffing. So yeah, I love to give judgmental conversation, but this is based on a lot of empirical evidence, right? Backed up by stats. All right, 8:24. You guys want to take a quick break? Yeah, then afterwards, I'll spend some time to talk about classifications. Afterwards, associations. And if you guys keen, some of you come from math departments, right? Let's talk about linear programming. Linear programming is not programming, not coding. It's talk about how do we use objective functions and constraint to optimize things. A bit only. I do want to reserve some time to talk about the code. How many minutes of break do you want? 10, 10. I think don't do too long. I think I have a lot of stuff to do. I also want to spend some time to let you guys introduce yourself as well. Yeah. I'll take a picture to do a count how many students are. I still feel probably about 50. Okay, now don't move first. Don't move first. I'll use the GPT to take the pictures. Okay, we see you 8:36. Okay. Do we still have time? Maybe one or 2 minutes. I do want to address a little bit about the project and quiz. I think some of you came to me to say, sir, can we change to a different dates? And in fact, a few of you came to me propose different dates, right? And there are also a few of you came to me to say that, sir, thank you very much. I think I will make sure I'm available on that date because the week before I will not be around, and the week after so I'll fly off for some critical things. So I think it will be very difficult if I really need to accommodate your personal preference to make sure all of you can choose accommodate all of your habits. I think it's almost mission impossible given so many constraints. So I will suggest if you could adjust your personal schedules and try to come for this quiz. But if you have medical reason, that's a different stuff, right? Notify me in advance, and I will try to have a discussion with the school departments to figure out how can we handle for those situations. But if I say, sir, I want to take holidays, I will not be able to accept that as a legitimate reasons. Okay, you come here for master studies, you invest your time and resources and trying to make sure you're not just get a certifications, right? You come here really spend meaningful time, 1.5 years of US to learn some things. So that's my wish. But if you really have difficulty, come to talk to me. I will see what can I do for you. But don't tell me you need a holiday. That's you shouldn't even come to talk to me because you have a holiday. You have to skip the exam. Or if you're mentally prepared to say, sir, don't worry. I'm very good in doing projects, right? I make sure for quiz 2 I score good marks. So even skip quiz number 1, I will still have a passing grade. My focus is to get a passing grade. I will see, you can try, but I will see good luck. Yeah. You guys are all adults, know how to make your personal choices. I won't prescribe to say what can you do, what you cannot do. I leave the decision to you guys. I did try, but unfortunately it's very difficult to find a common slot. I can't postpone the quiz to 2 weeks later or 3 weeks later. End up I have to do quiz 1 and quiz 2 all together, right? I also need to spend time marks your quiz. I think it's very difficult, right? Trying to accommodate, if you can, adjust your personal schedules, make sure you appear in a quiz. And also, I think bring your fully charged laptops. If you have a gaming PC somehow cannot run very long, you make sure you find a seat next to the power plug. This is a basic thing you should do in advance. I will not be able to bring 10 different PC to stand by. I also don't have 10 at home. Yeah. This is a class, so you should say nice. If it's in working environments, for those of you working before, right? If any staff come to tell you, I'm sorry that, trying to advise them, maybe you should spend time or spend efforts to buy a new PC. Yeah. Okay, projects. I think just last week we have somebody volunteer. Sorry, what's your name? Not Tanya. Yeah. Sumita. Okay. Sumita volunteer to be the class rep, helping to coordinate a bit on the project side. Not to do your projects, just trying to coordinate. Do I have a second bidder? Very democratic, right? If this is elections, is she the only one qualifying for this role? What over? Calling once, calling twice. People probably see this more of obligations than I see. So thank you, Sumita, for So you help. I already create the grouping that in the canvas, right? So I think I just look at the stats. There are a few students drop the class. Maybe due to the last lecture's effect, right? People feel too difficult. We have 92 students registered for this. So we were going to have projects size maybe 9 to 10 students in project groups. Maybe Sumita, you can help me to collect the names, and maybe warm up a little bit, make sure that people can find the groups. I'll be the one who doing this, I think, in charge of the final group allocations, right? Not Sumita. He's the helping to do some coordinations. That's one. And also, each of the project teams trying to give yourself a fancy and interesting names. You got 8 or 9 people come together, right? Yeah. You want to give yourself a good names, like a slogans. Yeah. A couple years ago, not in this class, they call themselves, I'm teaching another banking lessons, they call Blackpink in bankings. Okay? Or another teams, they have 7 guys and 1 lady, they call Snow White and 7 Dove. Yeah. I mean, you can call any name, right? But respectful and professional. Don't call something which is not acceptable, right? So that people can notice you, and because eventually your team will come here to do presentations. I'll probably bring somebody take picture with you guys. For that day, you know, right? I'll dress slightly better than this, maybe minimally with a jacket, probably with a tie. You guys, for guys, minimum like this, don't wear slippers and t-shirt come like this, like a chairman of the board, right? Like a professional. Ladies, makeup. If you can, not compulsory, but I do encourage you guys to do that. As if you present to the CEO of a companies. You don't want to lose points just because you don't dress up professionally, right? I'm trying to prepare you guys up. You know, after graduation, some of you want to look for jobs. These are tiny, tiny things. All right, let's go to a quick introduction, continuations of some of you, I think, who have not introduced yourself yet. As I say, this is also a good way to gauge how many students are showing up in the class, right? This is lecture 3. If less lectures, I continue to see the attendance rate not great, I will institutionalize attendance markings. For those students consecutively not appear for 3 times, come to see, not see me, I will be too busy, because 30 plus people queuing up to see me, right? Trying to explain why you are not showing up. Yeah. It's not trying to be difficult, it's trying to be responsible. I don't want to see any students not showing up in the class, just come for quiz and expect you will pass. It will not happen. I've been teaching here for 8 years. I think I will let people have that kind of behaviors to pass the class. Even I want, you're going to fail. Okay, NUS is a reputable schools. I do wish all the students be professional enough to uphold the standards. Let's say, where do you stop last time rounds? Is it H? I think probably still H. Xuan Tao, have you introduced yourself already? M ready. Yong Wei, Ivan, okay, Ivan. Jia Zhimin, cover ready? Emma, Marcus Kunyu. Bo Han is here. Li Lianyi. Okay, he explained to me he got medical reasons. Tian, Emma, okay. Zekai, have you introduced yourself? I'm just trying to check the boundaries. Zekai, you around? Yi Hang. Yi Hang. Yan Han. This one, I guess, no lah. It doesn't even have lock-in signs. Richie. Okay. Don't worry. Have you introduced yourself already? Okay. This to me is an outlier, frankly speaking. I've been here for 8 years. It's very rare for me to see this. Yeah. Okay, Ray Yao. Wendy. Do you mind to introduce yourself a bit more? Okay, thank you. Anything about yourself on programming? I think it's good enough. Yeah, you don't need to know more for this course. Thank you, Wei Di. Then Junwei, Niu Junwei. Okay. Zhong Yang. Nobuyasa. I think last you did introduce yourself, right? Big muscle man. Pan Jinghang. Free of charge? I want to join your teams. Wow. Future project partner, right? Okay. Okay. Thank you. Just to be precise. Okay. Thank you, Jinghang. Pang Bo. Okay. Okay, where Yao Ming used these days, right? Okay, okay. That's my days, right? 20 years ago. All right. Thank you, Pambo. All right. Next one, Junwei, Peng Junwei. Yes, Junwei. I see. This reminds me, Jing Hana, but do you buy snacks for your teammates? Okay, okay. Okay, all right. Thank you, Junwen. Next one. Hao Wen, Qian Hao Wen. Yeah. Okay. Okay. Some data science experience, right? Okay. Good to know that. That's the stage number 5 and 6, right? Consumptions and analytic transformations. Thank you, Howard. Next one. Shen Yang. You're more friendly than AI. Okay. Okay. All right. Thank you, Shen Yang. Next one. Shi Yu. Wow. Mm. Okay, thank you. Wow, you see, in a nice way, people want to clap for you. Yeah, yeah. Have you already found a team? Already found a teams. Okay. By sell so hard, huh? All right. Yuan Peng. Sumida.
Hello everyone, I'm Sumedha. I'm currently studying in QF. I have previously done mathematics and computing in my undergrad. I have experience working with Python, and I guess for this course I'll be your class representative. And I chose this course because I have some experience in data science, and as a data scientist, more or less we do take data engineering part, like we take it for granted that somebody else is gonna do that work for us. But when you start from scratch and you don't know like how do you even source the data to work with and stuff. So I just wanted to learn what happens before the data science part. That's why I just
Thank you, Sumida. I suppose you already formed your project groups as well? Okay. Junhen. Tan Junhen. Tang Liren. Yes, Liren. Okay. All these are easy things for you, right? Software engineer. Yeah. Okay. This is like master of all. Wow. Yeah, I suppose that you already people get approach you to form a project teams. Do you have still vacancies? 2 more. Okay. All right. 丽人 Tanya.
Hi everyone, I'm Tanya, so I'm a full-time QF student. So before I pursued my master's, I was working as a data scientist for a bank for a couple of years. So for my teammates, hopefully I can benefit with technical skills and some industry knowledge, but I'm looking forward to learning from you all persistently as well.
I see. You and Sumita form the same team? And do you still have vacancies? Too popular, right? Oversubscribed. Okay. All right. Thank you, Tanya. Then Talia, Callista. Oh. Oh, 3 of you. Okay.
Hello everyone, my name is Maria. I'm now in QF full-time. I'm previously also studying in economic finance, and I previously worked on more of the financial projects rather than technical projects. So, and I want to enroll in this course because I want to learn more about the engineering part, because I believe that it is very important to know like the basics of like how to
Thank you, Tanya. I'll assume 3 of you form the same clusters, right? All right. All right. Kampui. Okay. Software engineer. Real deal. Real-time working experience. It's not real-time, so real working experience. Oh, bachelor. Okay. Degree. Okay. Okay. I see. Jealous, huh? Okay. Thank you. How should I pronounce your name? Swan Che. Learn more about data engineering. Okay. You already find a teammate? Wow, thank you. And sometimes the data could be misleading, right? But look at the sign-up page, it's pretty empty. Suddenly when I start to ask you, all the data points start to pop out. I already find a teammate. Yeah? All right. Junya. We're trying to finish all today, huh? That's why I think we squeezed the break to 10 minutes so that I don't have to do that. Ziang. Wang Ziang. Wampaga. Yuqin. Wen Yuqin. Yes, Yuqin. Thank you, Yuqin. How many more do we have? Wow, so many. Okay. Trying to do a bit faster, so I'll finish that. Okay. 语境，宾语 Yes, 宾语 please. Do you mind to speak a bit louder? Okay. Oh. Yes, I can tell. You are showing up in this class. Yeah, I see. Anything about yourself you want to sell to your... do you already have a project groups? Okay, settle. 宾语温宾 I'm worried that I don't have enough space to write it down. 泽涵 Yes, 泽涵 I see. Thank you, Zahan. Yeah, I noticed, I think, based on the past, maybe today's 20 plus the data points, plus the last 2 lectures, right? When you guys introduce yourself, you typically introduce yourself, who am I, where am I come from, right? After some reminder, you start to add in some selling points. Yeah, I'm good at Pythons, I have some working experience. But so far, none of you, again, not to say you shouldn't do that well, none of you have highlighted your past achievements. My name is Huaxin. I graduated from a bachelor degree. In the past, for all the past projects, I always get A+. The teammates who are working with me always get the top scores. That's my credentials. I'm joking, I'm not saying I am, right? Sometimes you use the past evidence to indicate how good you are. It's also some selling points, right? As compared to I know Pythons. Right away, all my past projects, be group projects, individual project, all A+. Okay. But don't sell the fake information. Then later your project mates say, you see A+, you try hard enough. Okay. That's the business knowledge I'm trying to share with you guys as well, right? How to present yourself. All right. Next one. 异国. 谢异国. Xin Hao Fei. I really don't want to know your names in this way. Xin Li Wen. Okay.
Hello everyone, I'm Xin Liwen. I come from China, come from Shanghai. My background is mathematics, and I'm very good at programming. I use Python and R to do a lot of programs in the internship. So, I don't have a team, so everyone who wants a teammate, you can trust me. Thank you.
Facing them, yeah.
Oh, sorry.
Okay. Thank you, Liwen, for showing your current status, right? You're still looking for teams. All right. Bowen. Xu Bowen. Yan Zhaojun. Yes, Zhaojun. Okay. But this year lecture different from last year, huh? But thank you, Zhao Jun, who have the confidence in this course. The contents, I think, the core concepts and principle won't differ too much, right? It's just that different lectures come here to deliver the contents. Jian Yi, Yang Jian Yi. Yes, Jian Yi, please.
Hi everyone, my name is Tian Yi. So I was previously majoring in mathematical science from NTU Singapore, and I aspire to become a great quantitative researcher slash trader. And I have two previous quant research degrees, and I'm pretty familiar with Python data analysis, and I'm pretty good at playing chess.
International chess?
Yeah, international.
Okay.
So
Do you know?
chess.com, and I have a pretty high rating.
Wow.
I challenge everyone to play with me.
Okay. Wei, do you know him? Both of you come from type semi interest, right? Okay. Okay. Xiaoran, Yang Xiaoran. Yang Yao Yao. Hmm.
So I have handled some, I have done many projects about data analysis before.
Hmm.
So like, yeah.
Thank you, Yao Yao. Lu Yang, Yao Lu Yang. Cool and practical. These two things usually don't come together. But maybe, right? Thank you, Lu Yang. Last of you, I thank you guys for being patient with me. I did want to finish this today. Pei Hong. Yu Pei Hong. Yes. Okay, make all the PPT slides more beautiful. Okay, and Pei Hong have working experience before. Thank you, Pei Hong. Ziyu, Zhan Ziyu. Okay. For internship. Okay. So you don't have a project team yet? You don't have a vacancy? Okay, all right. Okay, thank you, Ziyi. Right? Maybe I think I come to you a bit too late, right? If in lecture 1, lecture 2, your marketing message will still be very attractive. Yeah. 博文, Zhang Bowen. 张丹明，丹明，张丹萌，OK。Okay, thank you, Daming. All right, yeah. Last of you. 今天 do faster. 小许，张小许，郑康瑞，康瑞，Okay, so you may not be able to highlight your skill set, but you have a good attitude. You try your best to finish the task assigned to you. Okay, thank you, Kanri. 周俊义，周立伟，立伟 ，Yes. Okay, well, all 3A plus in last semester. Okay, thank you for being inspired by my earlier sharings. Yeah, all 3A plus. Okay, thank you, Li Wei. 周衍之，周志普 not here. He's what? He's absent. Okay, he confirms absent. Tell you, right? Okay. All right. 周子然， The last one. 卓文杰，卓文杰。I so much hope when I write the names on the board, these are the offered by some of those good company in this world, right? From JP Morgan's, from Google's. Yeah. Anyway, yeah, I'll deal with that. All right, thank you very much for your patience. I think in the next class, I'm going to spend time on this, right? Today, I'll probably spend 20 plus minutes, right? That's all, right? If I need to, afterwards, if I need to mark attendance, I'll get a QR code, right? You guys scan there. Let's say a monitors, how do we deal with this? Yeah, I understand some of you probably because this. I have to switch to this. I understand sometimes probably because there's a lecture recordings, hence I think you choose not to show up, right? I don't want to dispute on that, but attendance rate like this, not good, okay? All right, let's go to the course notes. I think I already finished what is the clusters, and you guys know what's the reason why we're doing cluster in the business setup, right? Voice quality is not as good as this. Let me try this again. Testing, testing. Okay, coming back. Is to reduce the problem dimensions. And cluster typically is unsupervised. Unsupervised means that the data set doesn't carry a label. If you're still confused what a supervised, unsupervised means, go check it out. Ask your GPT friends. Yeah. Classifications. The example I'll give you there to see that sometimes before you send in the promotional message to your clients, you want to know who are the one potentially response, who are the one may switch off that. I think there's some echo here. And who are the one were not likely to respond. And you want to draw a line and to divide your clienteles based on in two parts, likely to respond and not likely to respond, right? So that's a binary classifications. And similarly, in many other scenarios, you want to see who is the potential suspicious clients that may be involved in, criminal activities. You want to draw a line as well, right? Cut or divide your customer base into two categories: the good customers and customers essentially give you problems. Some of you probably will feel, uneasy or a bit, surprised. Why there are criminals to be bank customers? They're not a criminal, I think, in our thoughts, right? The gangsters are fight on the street. No. Sometimes those criminals could be money launderers. You guys know what do I mean by money launderers or money laundries? I think now it's got no reason it's not working out. Fully charged batteries. All right. So money laundries means in Chinese called 洗钱, right? You bring money not unauthorizedly, illegally from one place to the other place. People see the money is very easy to carry. Why do you need to, find tricky ways to move money from one place to the other place? If you have money, $1 million, $2 million, you want to bring all overseas countries, not so difficult. You just need to create a bank account and prove your SOW, source of wealth. So how do you get this money? And use bank transfers, right? But a lot of times, it's not easy to justify how you legitimately get those money. For example, if I am here standing here, if I need to remit or transfer 500 million Singapore dollars to a Hong Kong bank account, if you're the bank officer, would you suspect potential, I got some issues for your concern, right? Transfer $5,000, probably you say that guy maybe have enough money, right, to pay. $500 million. And you can't justify where do you get the monies. Then you might be potentially identified as a suspicious customers. And you may very likely indeed could be a potential criminal trying to bring the money from illegal sources, move them and merge them into the financial ecosystem for other purpose, right? And typically people involved in this will be drug lord. They sell drugs. Or somebody involved in deep scam. You know what happens in some of the ASEAN countries, right? And so you do want to identify patterns like this, stop them, make sure they're stuck in the financial ecosystems, and so in a way they are less incentivized to continue their crimes. All right, so for that, you can also do classifications as well. So come back to here. What do I mean by classifications? In layman terms, you draw lines, separate or segregate good from bad. Customers who likely respond from those not likely response. Customer who commit crimes, financial crimes, and to customer not likely to commit, right? Binary, most of the times. Then, how do I do such classifications engines? One of the common one will be decision trees. You guys know what is decision tree? I think, do I put enough examples here? I didn't put an example of decision trees. So decision trees essentially help you to mix various different decisions. For example, if I want to make a predictions, whether that person is a student or not, right? Decision tree allow me to branch. The first thing I want to check, age. 0 till 10, 11 till 17. This is the features. This is one of the parameters I can check, age. I branch out into 3 different conditions. Less than 10, 11 to 17, 18 and above. If people come to here, then I'll talk about so-called infer whether these are NUS students, right? Right away, the answer will be no. 11 to 17, half no, half yes. Based on my samples, half of them probably yes, half of them probably no, right? So 18 to 25, maybe 70% yes, 30% no. That's the predictions. If I need to draw a line to say, I want to really make a line to say that how do I segregate NUS students from non-NUS students? Based on this simple matrices alone, age, right? I can probably, this is like 50-50, huh? I can probably draw a line here by using age alone. Anybody in my sample size more than 18 years and above, they are NUS students. Below, they are not. Of course, I'm going to make mistakes, right? Because based on here, my prediction accuracy is about 70%. Because the other 30% are not NUS students. And similarly, I'm going to have false negative as well. Some of those, which I think are not NUS students, they're actually yes. So in order for me to improve the accuracy, of course, I need to continue to branch for the decision tree. I add in more parameters. What other parameters I should add in? I can probably add in your high school or your bachelor school GPAs. Assuming your NUS CAP, sorry, high school GPA, I don't know. I think I haven't away from high school for too long, right? low, medians, and high. That can probably help me to filter to another round and allow me to have a higher accuracy. So decision tree is to keep on finding features. You split into different branches. End up you're in a bottoms. The bottom sometimes people call it is a leaf node, right? To say what is the eventual predictions. I'll only be able to explain to you in a very, very layman terms, right? Because really come to understand the details, you have to attend another lectures of mine. And of course, if you guys are interested in, I can share one chapter of lecture notes just to explain all those things in details. Yeah, you have other way to do classification like logistic regressions. You can also combine multiple decision trees together to form a forest, right? Adding some other features called random forest, right? This is the typical classification engine you can use and apply in doing segregation, good from bad, right? Customer who likely to default are able to pay the loan from normal customers. Customer who do money laundries from good customers. In many, many, many other different scenarios, you can apply this binary classifications, right? And there are also a way to evaluate the efficiency of the classification engine. Sometimes they call classifiers. I think that one is quite important. I think I will show it to you as well. But I won't go into details. Otherwise, there are too many matrices to cover. Let me erase this properly. This is called confusion matrices. Every time when you use a classifiers, you're going to make a predictions, right? Binary cluster. True or false. In this case, good customers or bad customers. Customer going to respond to your campaigns or customer not going to respond to your campaigns. That's the prediction from your model, from where you draw the line, right? Those above the line will be positive cases. Below the line will be negative cases based on your predictions. And don't forget, they also have actual values. Your prediction is not 100%. It will never be 100% accurate for all the scenarios. Sometimes the predict true may not always be actually true. So you have an actual label for the data points. Client A, predict actual. Predict respond, actual not respond. Client B, predict respond, actual respond. So for client A, the prediction is they are going to have a response, or true, right? But actual is not true. Client A contribute one count here. Because there's a mismatch, right? Prediction say, yes, you will respond. Actual one, no, just ignore your offer. Client B, they say prediction is response. Actual also response. Another one. One here, right? True and true. You keep on enumerating through all the client's response. You keep on adding one here, plus one, plus one, plus one, plus one. Here the same thing, right? So eventually you form a count in each of the cells. This one called true positive. Given is true, predictor also true. Accurate. This one is called true negative. You also have false positive, false negative, precision recall. I think in this class, I will not be able to afford to spend the time. For those of you who are keen to understand how do we evaluate a classification engines, confusion matrices is the one you go. Derived from that, you got F1 score, RLC curve. I only give you a starter. For anybody aspire to be a data scientist, you cannot run away without knowing classifications. There's a no, no, no. Data engineer, of course, you don't have to, right? But if you say, I want to be a good data engineer, I know also the downstream and the business, then this one you should know, but you don't need to go very, very deep. For example, how do I deal with the biased data sets? How do I do oversamples, undersamples, active learning, etc., transfer learning? Different story. You don't need to go there deep. So long you know there's such a thing, right? So the one I share with you today is actually a problem statement template. It may seems to be straightforward, but it can be applied in many, many other scenarios. A lot of times in the business world, once we form the business problem statements, we're trying to match and check against some of the common technical problem templates. I will see whether it can be used or not. For example, the example I gave it to you, right? Upsell, cross-sell. Right away, I can tell this likely is a classification problem. I need to identify who are the one will receive, will accept my upsell offers and cross-sell offer. Binary. Classifications. This is how you map the business problems, right? Same attritions is the same thing. I want to identify the customer who is likely leave my companies, not continue to bank with me, will not purchase the product from my e-commerce platforms. Binary, right? Classification again. There's so many scenarios that you can apply classifications. That's the reason why I'm saying it's so important. Similarly, come to targetings, right? Clusterings will come into pictures. There's one more called associations. So these are the three typical data mining. Again, I'm not saying data analytics. Data mining techniques. Association. What do I mean by associations? The word itself tells you association refers to the common things happen together. Why do we need to learn that? I'll share with you one example. The notes you can go through, I won't go through the details. I think otherwise it's taking too much time. One of the typical association methods called MBA. This MBA is not a Master of Business Administration. This MBA refers to market basket analysis. It's original from some study on some supermarket data, I think a few decades ago. People observed. They analyzed the supermarket's transaction data. They noticed the men who choose to buy beers from supermarkets also buy diapers. They notice these two things happens in high frequencies. But this sounds like a correlation, right? But what business is going to use this? Yes, I know. Men will buy beers together with diapers. From the transaction data, I see these two pairs likely happens very frequently. As a supermarket operators, so what? By knowing this, what should I do? Go around to tell good things about the men, right? They never forget to buy diapers for the wife. From business angle, how am I going to utilize that? There are two ways to think about this. Because I know these two were purchased together, I should place these two items next to each other so that I won't have the potential loss of sales. Maybe some men are a bit lazy, right? They just don't want to go so far. I place the two items next to each other so that they always buy. Increase or enhance the customer's convenience and for shopping experience. That's one school of thoughts. The other one was school of thoughts. This have been commonly used in some of the hypermarkets. Given the fact I know you have the needs. When you buy beers, later you want to buy a diaper, right? You have the needs. I purposely put those two items further away so that you travel within the supermarket. When you spend more time in the supermarket, you have a higher chance to buy other things. This is also some of the shopping malls designs as well, right? You see the escalator, usually you will see after they come down, then right away you use the immediate escalator, right? No, immediate next escalator is not below you, it's on the other side of the shopping mall. So you have to go all the way to the other side, take down again, then you have to go one level down, you go another side. They're trying to maximize the time you spend in the buildings, the time you spend in the supermarkets, right? So those insights can tell you something about the customer's needs. Associations. Similarly, this can be applied in banking sectors. This can be applied in understand the customer preference for the trading portfolios. The same thing. So by understanding through clusterings, classifications, and associations, you roughly master all the data mining techniques. But is that all for data analytics? No. There are other stuff. NLP, natural language processing. It doesn't really belong to these categories. Image recognitions doesn't really belong to these categories. Operation research doesn't belong to these categories. Of course, operation research will spend some time to talk about it as well. Yeah, but later. Forecast doesn't belong to these categories. So as the mature data analytic professionals, if we really want to master some of the key techniques, there are a lot of new things we have to learn and keep abreast the latest changes and developments in the fields. For example, forecast. If I need to forecast the price of the stock, and for your information, people already proved, right? The price follows some stochastic process. It's not too easy to forecast, huh? Yeah. So, should I use clusterings? No. Should I use associations? No. Then what should I use? The typical methods people will use is called time series forecast. It's a time series, right? Based on the past empirical data, you want to project the future ones. And there are numerous different methods available. Again, it can be a standalone class, a standalone modules. I summarized the key things I think put in the notes. You guys know ARIMA? Heard about it? ARIMA is the time series methods. Autoregressive integrator with moving average. This is what ARIMA means. AR and MA. AR stands for autoregressive. MA start to moving average, the dealing with the own values or error terms. I stand for integrated, right? So of course, ARIMA has been evolved. I think ARIMA X, you have the regressors, etc. Right? There are other terms that dealing with. For those of you study forecast before, the most basic one is probably hot winter models. You're dealing with a level, you're dealing with trend. Again, there's no way for me to give you a so-called intuitive story, help you to understand the key things. I can highlight a few keywords. So if you are interested in, at least based on a few keywords, you can take a deeper dive, right? The keywords will help you to move into a direction. Not for you to understand the concepts, that would be too little. Level, trend, seasonalities. This something, talk about the time series signal, right? This is level. Level 1, level 2, level 3, right? Level tell you something like average values. Yeah. Trend tell you how fast do you move. Like this, like this, like this. Seasonality tell you that whether every time during the Chinese New Year's or month's end, right, there's a traffic for people spend. That's the seasonalities, right? By capture these three different signals together, typically you're not going to have a very bad forecasting accuracy. Understand the average values, trend up and down, what's the slope and seasonalities. That's the time series forecast. Yeah, there are multiple different so-called machine learning based. The one time series forecast like hot winter models, ARIMA, they're not machine learning based, they're purely time series. You can also do machine learning based forecast as well by using something similar along this line. This is the simplest equation we'll ever learn, right? This, of course, is linear. Yeah. Y is the one you're interested in. Dependent variables. X is your independent variables, right? K will be coefficient, B will be intercept. This can be vectors, right? In the simplest form, if you want to predict the stock price, find all the parameters relevant for and which you think will be able to explain to Y. Try it out. Of course, linear regression typically will give you very poor fittings or accuracy. R squared probably will be very low, right? Then you try different, maybe non-linear approach. Or people essentially try deep learning models, right? To model the non-linear relationship. It's just that I think you need a lot of data points. Okay? Then the next one, I think besides forecast, the next one will be optimizations. And that's the one I think which is very, very interesting, which is something I probably spent many, many years doing research in. What does optimization do? Something relevant to you. If you have 13 weeks, you come with some Python experiences. You need to pair up with 9 different people to do a project. Your goal objective is to maximize the score for your project. The constraint is that you only can commit X number of hours. Your skill set is maybe strong in programming, weak in project management, etc. Right? These become our optimization project. How are you going to allocate the time and tasks among yourself so that you get the best score possible from all the 9 or 10 different peoples? This is the optimization problems. There are multiple different combinations. Maybe in Tanya's teams, Tanya will be the one. One option is that Tanya do everything. Coding, find the data, clean the data, doing presentations. That's one option. The other extreme option, Tanya didn't do anything. Just be a role model. Encourage people, be a cheerleaders. There are multiple different options, right? Maybe Tanya focus on doing coding. Maybe Tanya focus on doing PPT slides. Maybe Tanya focus to buying free snacks to cheer the team up, while in the same time helping on others, right? There are more than one way. In fact, there's numerous different ways to assign the resources in order for you to get a good result from the projects. Which one is the best way? In view of the goal, higher score, higher outcome for the project. How do you know? Optimization help you figure that out. People will say, sir, it's actually very easy. I try all the possible different combinations. And I choose the one with the best objective function values. Can or cannot? Can, provided your problems is small. You guys heard knapsack problems? So both of you studied OR before, I say. You carry a bag. There are multiple different items of different size, but each of them carry different values. You want to bring back the one with most amount of values. Then your decision is for you. Which item should I put inside my bag? Maybe some of the big items that are more valuable but occupy a lot of space, and I can put in 1 or 2. The small item, less valuable but occupy less space. Right? So you need to figure out, subject to the space or capacity limitation of the bag, what is the right combination of the item to put in your bag to maximize the values. You can, of course, try all the possible different combinations. But imagine we're not carrying a bag. you carry a ship, container ship, right, big boat. The amount of combination you can do is astronomically big. You can't try all the possible combination and figure out the best one. So some of the maths probably start to come in. You start to prone the solution space, find the good corner points, etc., etc. Right? I will not give it to you, and share more details. And the problem becomes actually difficult when the decision variables are integers, right? So you're going to deal with the combinatorial problems. And for those of you who come from computer science, then it's the time for you to start to touch whether P equal to NP, right? I don't want to further confuse you. So why do we need to do optimizations? Some of you probably still remember the analytic roadmaps I shared with you guys in lecture 1 or lecture 2. After understand your current status quo through descriptive analytics, after you can predict what's going to happen in the future, the next thing you're going to do is to optimize the resources, right? So as somebody who aspires to be a senior data professional, after you know data engineering, how to do the data, or after you master some of the basic data mining skill set, if you want to continue to go deeper, think higher, optimizations recommends you trying to understand and know a bit more, right? Not a lot of company can afford to do that because it's a cost investment, right? The company also needs a scale business, otherwise the ROI is not very, very visible. But for somebody as a professional, knowledge I think doesn't have a bond, right? So you should consider. All right, I think I cover most of the stuff. OR. Generative, I think business use cases, on and off, I think I weave in a few, right? And maybe next lectures I can continue to talk a little bit more. I also today, I doesn't have the time to continue to run through the code with you. Next lecture I will do, right? That's actually very important. I do want to make sure you guys really know how to run the Python code, how to have a brief understanding, right? Trying to do your homework, understand that a bit more using the support for GPT. But next lectures I'll go through with you in details for some of the key Python statements in the Python script I upload in the canvas. Yeah. So any questions? Any questions? This is actually to help you to prepare for your projects. Also cover a bit of a typical analytic use cases to inspire you a bit, right? What potential projects you can choose? Questions? No? You guys all okay? So I'll upload, I think, the joint lecture notes or examples in the canvas, and also try to spend some time, I think, to read. Lecture 4 notes, I think, will be a bit more technical, right? It's not just like a high-level stories for me to share with you, like today, the use cases, spend some time. I'm also in the middle of prepare so-called a quiz. Just now a chit-chat, I think, with you guys, right? To give you a bit of a candies, yeah, we have about 90 plus students here. For those students, for quiz, who score, I prepare to see the top marks, will be thinking, for score full marks, I'll be thinking to give you guys something, right? Maybe I think you come to my office, we have a lunch together, or maybe dinner together. Last time around, not in this class, I purchased a pair of concert tickets for the top score to give it to them. Yeah. You guys know Blackpink, right? But this year, no, right? They won't come to Singapore, right? Maybe a meal, right? So for those who store full marks for your quiz 1, whether it's 1 or 2 or 3, I will probably invite you for lunch or dinner together, just to, not stay reward, just to recognize, I think, your good performance. Or you guys say, no, meal not nice, I think I want to do other stuff. You guys have any interesting stuff you want to do? Budget, okay, I'm okay with the budget, right? Not unlimited. If a meal you feel sad, I think doesn't have to kick. What else do you guys want to do? A trip to Europe? No, too expensive. Maybe a trip to Pulau Ubin can, right? think about that. I think I really want to, to show some recognitions to those top performers, right? You really spend time and efforts to make sure you're doing well in this class. All right, I think I will see you guys next week again. And feel free to post the question in Canvas. Yeah, this is a tough subject for some of you who doesn't have the backgrounds, right? Spend time. Trust me, after graduations, you're not going to touch the lecture notes anymore, right? This is the only time you're going to spend some efforts on this. Cherish this opportunity. Just like me, I've been here for so long, right? Every time I see new fresh face, I always cherish. These are the stuff I think I probably talk for quite a few times, right? But I still have the passions and kick to share with you guys. I hope you guys reciprocal, not to me, to the knowledge you need to acquire to stay competitive in this world. Yeah. Next week, I'll spend some time talk about generative AI stuff as well, right? It really changed the field so drastically. As some data scientists like myself, right, I feel my role has been morphed in a slightly different ways. I'll share more. Tonight, I don't want to be long-winded. I also need to take a picture of so many names on here. Okay? Thank you guys very much. You have a good night. See you next week.